Okay, guys, so now we're going to go into naming rules. But first we have to talk about there's 4 types of bondings, but we're really going to focus on 2 naming rules. But we have to talk about bonding first because there's different naming rules because of the 2 different ways they bond. So, first off, the 4 main characteristics, 4 main bond categories is all based on characteristics of how the compounds, whether they dissolve or whether they conduct electricity. That's it. So, and had we been in school, we would have done this lab and we would have seen if things dissolved and whether they conducted electricity. So here's really the categories. These top 2, these dissolve. These don't dissolve. Not dissolve. And then these guys conduct electricity. Oops, this is gonna... should have made this smaller. Whatever. These guys conduct electricity, and these guys, like this column, don't conduct. So yeah, here we go. Dissolve, dissolve. Do not dissolve, do not dissolve. Conduct electricity, do not conduct electricity, do not that's the main characteristics, right? I probably just covered my face, but whatever. Okay, so what does it mean to be soluble in water? It means that they dissolve. Funnily enough, soluble is the big fancy word for dissolving. And both of these things dissolve, but they dissolve differently. The 2 dissolvings, you got ionic, that they separate into they conduct, and molecular covalent dissolve, but they don't conduct. So why are they different? So funnily enough, ionic compounds, when they dissolve, they split apart into their plus and minus ions. So this is table salt. Na1, the blues are the Na and the greens are the Cl. 1A, Na, 1Cl. That's the structure. But when it dissolves in water, this is what happens. The water comes along and the negatives attract to the pluses in the water and the positives, it completely splits apart into 2 different things. But covalent bonds, or sugar, which is a covalent, it doesn't. So it stays as one sugar molecule. It just splits apart. It doesn't split completely apart like this. The fancy word for this is called dissociate. This doesn't dissociate. It just stays as one big clump. It just splits into smaller pieces. And this plus and minus, that's why it conducts electricity, because you need charges to conduct. Okay, ionic bonds. So there's this big, huge, long explanation right here, but it's not a big deal. Ionic bond is so the sodium runs into the chlorine and they fight, and then the chlorine, if the chlorine's the dog bone is the electron. Look, they're running to each other, they fight, this guy steals the electron, it becomes negative and positive, and then they just hang out near each other. And that's essentially all an ionic bond is. That's why it dissolves in water, because they're just hanging out near each other and the water gets in the middle. So, covalent bonds, though, the dogs run into each other and nobody takes it. They both keep a hold of it, and I call it dogs of equal strength. Or I think of covalent bonds as I got 2 twin nieces. I have a pair of twin nieces, and when they were 2 and 3, they never wanted to share. And so this is my twin nieces, both having their hands on the same toy. That's the way covalent bonding is. None of them wants to let go of the electron. They're just holding it equally. Another way of visualizing it is covalent bonds, they both keep a hold of the 2 electrons and they just kind of overlap. But an ionic bond, that electron completely moves over. Yes, baby.
That's G.
There's a G, yes. Now my daughter wants to be in the video, so here you go. So, the other 2 categories, the 2 types of bonds.
They
insoluble. That's the big fancy word for the not dissolving. We're not going to focus, too much on these guys because, we're not going to worry about the naming rules. That's really the thing. They don't actually really have their own naming rules. They get their own new names. So like a metallic bond would be their alloys, like bronze. Bronze is made of zinc and copper. Or it's just a single metal. So funnily enough, there is no bond, like, it's not two different things that combine. Both of these actually are usually just one thing. That holds together. So metallic bonds are literally, they're just the atoms sitting around, and there's all the electrons are just floating around near them. Metals, they want to give away their electrons. They don't have a very strong hold on them. Yes, the bones are the electrons, baby, and they're just hanging around. Yep.
Bones.
Dog bones. Yep.
Dog's bones.
And so again, just one more visual. You just have all these. They still have their positives, but the electrons are just kind of floating around. So funnily enough, metals conduct electricity because electrons are the things that are doing the conducting, and they're just floating around in there, and they conduct electricity. Yes, and network covalent diamond. All that is, diamond and graphite are only carbon. That's it. A lot of network covalent are usually just one thing. That's all carbon. This is just the spinning diamond molecule. Silica, yes, it's one thing, but they're all SiO4s. That's what just one. Funnily enough, I liked this. Carbon, just carbon. Just that's supposed to be a chunk of coal. When it gets under severe pressure, it becomes a diamond. So that's why your dad's under a lot of pressure lately. It's funny. Okay, so then this is the first time, actually it's the second time I've ever started with naming molecular compounds first, because you're going to learn this rule once and then you're not going to use this rule again. So they're made of two nonmetals. All the other rules we're going to worry about they all start with metals. So these are two nonmetals. So because of this sharing of electron things, that you can have any number of the two nonmetals, like so in order to say how many of each atom there are, we use prefixes. No, don't touch. Well, you can touch that one, baby. You use prefixes. So what the prefixes are: 1, if you have one of them, it's mono. 2 is di. 3 is tri. 4 is tetra. 5 is penta. 6 hexa. 7 hepta. 8 octa. 9 nona. 10 is deca. So this is real fast. So when you name molecular compounds, they're the easiest thing. So FYI, there's this naming rule, and keep for a second. I'm going to go to the periodic table. So the nonmetals on the periodic table, I wonder if this is, are just, okay, there's this invisible staircase that's not actually on here. It's just these guys. Just these ones. So yes, we're going to learn these naming rules, but it's really, okay, the circle really should be smaller than that. It's only when there's two of these guys, maybe arsenic, like these guys don't really bond with anything. So it's just these little categories right here, just those few elements are in molecular compounds. Let's go back to here. And go back to the naming rules. Go, baby, quit closing. From current slide. Okay, so here's the rules. Here's my examples. So let's just make something up. This would be a formula. P3C. So naming is when you see a formula and then you write the name. So the rules: first element keeps its name, we put the prefixes in front. The second element ending changes to "ide." So this is phosphorus and chlorine. The prefix is in front. 3 means, so it keeps its name. There's the prefix, but try phosphorus. Oops, PFOS for us. And then the second element changes to "ide." This is chlorine. The INE changes to IDE. So 7 is hepta and chloride. So we've probably seen chloride in names, but now there we go. So prefixes, prefixes, ides. Just on the second element. Let's do another one. Mono is not used on the first element, so we all know what this guy is. It is carbon dioxide. Carbon, it doesn't say monocarbon. And then ide. It's oxygen is oxide. No mono. See, no mono. Not used on the first element, but only the first element. So like if I have N3O, that is trinitrogen. Well, it's not like monooxide, it's monoxide. So I hope we don't need really any more examples than that because I'm out of room. And even easier then is to write the formulas. So it's just the reverse. So like if you see this, dicarbon pentabromide. So the prefixes go with the element. So dicarbon. C2, penta is 5 and bromide is Br. Baby. Two more. Let's say we have phosphorus. I used phosphorus already. Phosphorus. Tetraiodide. Phosphorus is just P, and there's no prefix, so it's just 1. Tetra is 4. Iodide is I. Try nitrogen, hexa. Oh,
I spelled.
You did. Hexa.
X.
That is an X. Good job, baby. Hexa. P. Phosphide.
B box.
All right. So don't. Oh. Okay. Good job, baby. Tri is 3, and it's nitrogen. So, and 3. Phosphide is a P, just like Anna said. P.
I did spell.
You did spell. Hexa is 6 and 3p6. So there you go. Really super easy naming rules. Now, after this, ignore the prefixes. We'll do more rules tomorrow.